Hello, welcome back to our second session and our atomic structure lecture. Right. Before, if you remember, we've been talking about the components of an atom. So we talked about what the nucleus is, we talked about what the protons are, we talked about what neutrons are, talked about electrons and how they orbit the nucleus, and together all of those components make up an atom. Now what we're going to be moving to is kind of what's the purpose of this? Like, how in the world can we figure out, like, how to identify an element, how to identify, the atoms that are inside of that element? And what we're going to do is we're going to talk about something called atomic number. So I'm going to get this big screen, and I'm actually going to be flipping between this document and our document that you guys are currently filling out right now. But on our first set of notes is something that we call the atomic number. And what we're going to be doing for this section is we're talking about the periodic table. Okay, the periodic table of elements is a list of all the elements that have been identified and are listed. Okay, so it's things like oxygen, it's things like silicon, it's things like helium and hydrogen and gold and silver. Okay, so as we go through here, we are going to take some notes. So the first thing we need to do is we need to write down atomic number. So let me get my little pointer thingy, and I want you guys to write down atomic number. So what is atomic number? It is the number that is equal to the number of protons in an atom. Let's go back. Remember, a proton is the positive charged atomic particle inside a nucleus. In this case, it is the red circle. Okay, so again, a proton is a positively charged, a neutron has no charge, and an electron is negatively charged. The atomic number identifies which element it is when we go on the periodic table. So if we look at this part right now, actually I'm going to hit the say take notes, and you guys can then fill this information out. So take notes. All right, welcome back. So as we do this, we have a question for you, and you can just kind of say this out loud. How many protons are in this nucleus? How would we figure that out? We would count. So count with me. How many red circles are there? 1, 2, 3, 4. There are 4 protons, or 4 positively charged atomic particles. So that number tells us that the number of proton tells us the atomic number. The atomic number for this atom is 4. So what do we do with that? Well, we need to move to the periodic table. So here's an example of the periodic table. What we're going to look for is one of these elements that has 4 protons. In order to do that, we need to look at one that has a number 4. So number 1, no. 2, no. 3, no. 4. So this element has 4 protons. It has 4 protons, so this is the element that we're looking for. Question is, what in the world does Be stand for? Is it Bengals? Is it B, like a bee? Or is it like, who knows? We don't exactly know. A lot of times the periodic table of elements doesn't always tell us the name. Okay, it tells us the symbol. So the symbol is usually a series of 2 letters, sometimes 1 letter, that actually helps us identify the element. So when we look at 4, we can find out that it's beryllium. Beryllium has an atomic number of 4. What that means, it has 4 protons, 4 neutrons, and possibly the same, if not slightly different, number of neutrons. And we'll talk about that in a little bit. Okay, so what I want you to do right now is I want you to think, okay, what if I told you to find the element that has the atomic symbol of Cl? Take a second and see if you can find Cl. We look over here, right here, Cl, number 17. What does that tell us? That means there are 17 protons and 17 electrons in this element. All right, we're going to do one more. What if we look for the element of Fe? F as in Frank, E as in Eddie, Fe. So again, we look, we find it. It's right here, number 26. That means 26 protons, 26 electrons. That's going to play an important role in what we're going to learn about later on down in this lesson, okay? So what we want you to do is you are going to copy this down in your notebook, okay? And as you do that, you're going to copy the square and you're going to copy the arrows. This is important so you can identify what makes this up, okay? So how to read an element, put that in, and then you're going to put in the number of carbon. You're going to put the symbol, the name, and right down here, which is the atomic mass. Okay, please write in atomic number and use the parentheses, the number of protons, symbol, name, mass. Take notes. All right, so what you've done is you should have an element in here of carbon, okay? What we're going to do is we are going to practice doing this to another element, okay? So hold on for a second. My face is going to disappear. But on our document, okay, right here is there's a periodic table of elements. I want you to open it. And what I want you to do is I want you to pick one more element. And you are going to do the exact same thing you did here, in which you are going to write this in your notebook. We're just doing it as practice. So for example, let's say I pick zinc over here. I am going to, in my notebook, and I'll show you this, I'm writing it down right now. I am going to practice writing it. So let's go through zinc. 30 is my atomic number. I am going to write my symbol, which is Zn. I am going to write it out, which is zinc. That's the name. And then my atomic mass is 65.39. Atomic mass. So as I go back, you guys are going to see that Mr. Eddie and his lovely drawing has written down this. Okay, it's backwards. Okay, nothing pretty, but we can make it work. So if I flip it over, there you go. Now it actually makes sense on what it's looking like. Okay, so you should have two examples. You should have carbon, and you should have a different symbol. The reason why we practice that is so we know that you guys can write this down and you can understand when we tell you to read the periodic table, that if we say, all right, find an atomic number, okay? Find the atomic number of barium. So you look through the thing and you figure out, okay, it's 56. So we go through and we look and we find it at 56. All right, let's go back to our notes. So if you need to do that, pause, take notes. I think we're just going to start making weird faces in the videos because it's giving me something to do as we go through. All right, next step. Here's the video we want you to watch as kind of explaining the different elements. We're going to talk about certain parts of this later on. We are not going to dive super deep right at this moment, but I think you guys can kind of figure it out. All right, so I'm going to be quiet and I am going to play the video.
Hi, I'm Emerald Robinson, and in this What Is video, we're going to examine chemistry's most famous illustration, the periodic table. The periodic table is a figure that shows all the known elements arranged in a specific order based on their chemical properties. Chemist Dmitry Mendeleev is considered to be the father of the periodic table, publishing an early version of it in 1869. The modern periodic table has 118 elements. Elements are substances made up of a single kind of atom. Nothing smaller than an atom or made up of more than one element appears on the table. To understand how elements are arranged on the table, we need to review atomic structure. Atoms have a nucleus made up of particles called protons and neutrons. Particles called electrons orbit around the nucleus in paths increasingly distant from the nucleus, like layers in an onion. Chemists call these paths shells. Elements on the periodic table are arranged in increasing atomic number. Atomic number is calculated using the number of protons in each atom's nucleus. Rows, or periods, are based on the number of shells. The first row of elements, hydrogen and helium, have all their electrons in one shell. Elements in the second row have 2 shells, and so on. Elements in the same column have the same number of electrons in their outermost shells. Hydrogen and lithium each have 1 electron in their outermost shell. Elements in the same column have the same chemical properties. For example, the last column, which contains elements such as helium, neon, and argon, are called the noble gases. These gases are inert, which means they don't react easily with other elements. As more elements are discovered in nature or synthesized in laboratories, they're placed in the periodic table. Who knows what the periodic table of the future will look like?
Apparently we're going to watch that again. Let me figure out how to get out of there. Sure. Oh. You having fun with this? This is me screwing around and not knowing what to do.
Hi, I'm Emerald Robbins.
See, welcome to learning how to use all of the things on Zoom. All right, so it's reloading. I apologize about that. I could pause the video down here, but let's be honest, you guys are having fun listening to me chat. All right, one of the things that you guys are going to be doing is being able to kind of explain how the rows and the periods work, okay? So as we watch this video, and I'm not going to play it again, you notice that there are certain periods and certain columns that meant something, okay? We're going to talk about how they're arranged, and that's going to play an important role when we start talking about what electrons have to do with this and what electricity has to do with that as well, all right? So this is your next step. And what I'm going to have you do is I'm going to go through it first, and then you guys are going to go through and highlight and color and stuff like this. So how are elements arranged on the periodic table? All elements, and I want you to write this down as well, all elements in the same group have the same number of valence electrons and the same chemical property, meaning that they are very similar in how they interact with other elements. So what I want you to do is when I say pause, I want you to try to draw, this table in, okay? Use color. It doesn't have to be perfect, okay? I'm not expecting you taking a ruler out, but I do want you to at least draw this first part out. You can just draw a whole bunch of boxes, and red, orange, yellow, you guys have colored pencils. You can make this work. The part that's important right here is groups along the, once this goes away, the vertical columns. These are called groups, okay? So group 1, group 2, group 3, group 4, group 5, group 6, group 7, okay? There's 2, 4, 6, there's 8, sorry. There's 8 groups, okay? So when you start talking later on about groups, that's what you're gonna do. So again, pause, put this in color into your notebook. You should have the title, you should have this information, groups are along the columns, the vertical columns. Take notes. So in our video, if you remember, they had these groups, but now we're going to actually talk about periods as well, which are going to be the horizontal. Okay, so now you're going to kind of draw again the periodic table, and you're going to color in. A cheat sheet would be is if you could, somehow print out a small version of this that doesn't have any color and then go in and color it. That's great. Otherwise, literally just kind of make it up so it looks like this. So all elements in the same period have the same number of orbitals. Again, we're going to talk about what that means. So again, red across the top, orange, yellow, green, blue, pink, blue. You notice here, 1, 2, 3, 4, 5, 6, 7. There's only 7. This down here is actually this right here, okay? When you look at a periodic table, you're always going to see kind of these 2 rows down here. It actually fills in this information here. It's because we kind of know a lot less about these elements here, and they're very similar, and that's why they're kind of broken down into this section. Again, So again, you're going to pause the video and you guys are going to write in this information and talk about how periods happen along the horizontal rows. Take notes. All right, so not a ton of information here. You guys are going to have some questions down below on your document that you guys are going to need to answer here. That's going to go through, okay? We are going to be talking more and more about how the periodic table plays a role in what we're about to learn. But as we see, that is the end of this section. But by the end of the section, you should be able to identify what the periodic table is, how to find an element on the periodic table using the atomic number, what is the atomic symbol, the name, and the mass, okay? You guys will notice a lot of times that the mass isn't always double what the atomic number is. So in this case, it's 12.011, okay? That is something we're going to talk about a little bit later. It's not going to be the most important thing we talk about, but it is going to be there. So groups, vertical, there are 8 of them. Periods are horizontal. Okay, there are 7 of them. It's the number of orbitals. This is the number of valence electrons. We're going to talk what that means coming up. The end of group 2. Nice job.